second day. For this one, we're going to implement Legion ECS, and I'm going to do some unit selection where you can drag a box around a couple of units and they should be marked as selected. So that's what we're going to start with. So let's get going with Legion ECS. Okay, this is the second time I'm recording this because something went wrong with the sound, so I'm gonna try this again. So the first thing we're gonna do is create a new branch. And then we're going to add Legion here. So I need to copy the URL. There we go. Yesterday, GD Native was updated on crates.io to 0.8 from 0.7, and I'm trying that out now instead of using my local copy, which is from the master branch. So, alright, so we've added Legion. We need to add more things. We need to add laser static to this. And let's see, I think that's it. And then the next thing we're going to do is we're going to move the game world into its own module. Game world. So we're gonna take that, oops, and move it there. And then we can take that part and move that there. The other thing I did was create a module called GD Prelude. So I don't have to keep adding this part to the top of every module I create, every file I create. So then we can use crate. GD Prelude, there we go. And let's see, is there anything else missing? Well, yes, there is. We need to use GD Native, Node 2D, and input event. Okay, I think that's all right now. Right, of course, we can no longer call that just game world. We need to call it game world. Use the module, and then the struct. And I think that's all right then. Okay, we got some unused imports. Let's just get rid of that. And we don't need the GDP either. Okay, right. So no warnings, no errors. So that's pretty good. Okay, and the sound is seemingly still working. So let's see. The next thing I did was to add the Legion bits. Another prelude and laser static as well. So what we're gonna do is we're gonna add the universe and the world. And technically we don't need the universe if we only have one world, but since I don't know how I'm gonna set this up, I'm gonna add both of them. So let's start with sunk mutex. Let's start by adding the universe. So that's going to be a mutex holding a universe. You can have multiple worlds and you can have multiple universes with Legion. And I'm not entirely sure how all that works, but I know that you can have one world and then another world and then sync those together. So you can do a lot of work on another thread and so on and so forth. So anyway, let's get to it. Mutex, new, universe, new. Okay, I think that's it. And the next thing I did was add another laser static for the world. And this time we're gonna use our universe up here, right? This is the guy we're gonna use. Universe. And we're gonna lock it, and if this fails, it's gonna panic. But if we don't have a world, then we don't have anything. So let's just lock it, map it, and unwrap it. Create world, unwrap, and done. Okay. So the next thing I added was some utility function. So we're gonna add a comment because this file might get a little bit larger. I'm gonna call with world, where f is a mutable function taking a mutable reference of world. And here we're gonna call world.tryLock, because this time we don't want it to crash if it can't get a lock. Map, you know what, that needs to be mutable. Map world. Okay, and then that needs to be mutable as well. And okay, so now we have an unused result. And what we're going to do is check if the result is an error. Then we're going to call gd with world. And we need to use that gd extras, gd there we go. Okay, right. So if anything happens when I'm running with world, then we're only interested in the error for now. Okay, and the next thing I did, this is our go.node, so go.node. We need to add a physics systems, and that's systems, right? So we're gonna have several systems stuck into a schedule that we're going to execute on every physics process. So let's add the physics process now. Takes a mutable reference to self. Ignore the node 2D for now, and delta, which is a 64-bit float. And then we need to create the physics systems. Physics systems that has resources and a schedule. Okay, let's have a new function where we can add resources. It's just going to be the standard resource, the default implementation. And when it comes to all of systems going to run in the physics process of this game, we're going to add those here. So schedule is a schedule builder, add thread local, because we're going to move players, and the players are going to be go.nodes, and then we're going to build, and then we add the schedule, and then that's done. Okay, and then we can then call this. No, we can't because it doesn't exist yet. Physics. And then we need that up here. There we go. So now we can call self.physics.execute delta. No, we can't because that doesn't exist. So we'll add that first. And that does not have to be public. Execute, that's a mutable reference to self, and the delta time. And we're not going to use the delta time right now, so we're going to do that so we don't have to look at the warning. So what are we doing now? Okay, with world. So then we can call self.schedule.execute. It takes a mutable reference to a world and a mutable reference to resources. So world and self.resources. Okay, that's good. Let's get rid of that and that. Okay, it can sort of fit on one line. If it was any longer, I wouldn't. But let's see what Rust FMT does. Yeah, it agreed with me. Okay, grand. So, right, that's our physics setup, and that's our first. No, it's not our first system. It's our first schedule, and we are now going to move on to creating a bunch of components and entities. And we're back. Okay, so we're going to add some entities and components to this now. So what we need for that, we need to add, we're going to make the player entity is going to have a position and a kinematic body 2D, so we can move this player around. So let's start by doing the position. And we need to derive a clone for that one, I believe. And let's see, what do we actually need there? So use GD native vector 2, which is just a Euclid vector 2D at 32. Okay, so that's our component there. Let's see if this works. Yes, it seems to be working fine. Next thing I'm going to do is going to go and change the player. Okay, so this is now inheriting kinematic body 2D, but I think the player is going to have a kinematic body 2D instead. And let's drive the bug and clone. Now we don't need anything there. We can delete everything up to there and get rid of that as well. There we go. And this is our component now. Components, which is going to hold our Godot node, which means that we can't really be sending this node, this component, across threads, right? Because it's not sync. We're gonna take away all of this for now. And but we're gonna make our move system now. Okay, so let's fix that. So function move system. No, move players. And this is going to return. So this is gonna be the system that we run in our game world. So we have the physics system here, right? So we're gonna have add thread local move players. Okay, so we need to get that. Use create. Okay, so that's what this thing is going to do. It's going to move our players. So we need to implement this. This needs to return a box dynamic runnable. I'll find runnable. All right. There we go. And that can all be in one place. Okay. And what's the problem here? Maybe it's in create players. Okay, well that's because that's called player. So let's go and fix that out first. Players. Oops. Players becomes player. There we go. And the system is happy with that. That's all gravy. Okay, so let's go back in here and right. Okay, so we can't, we're returning a unit. We're returning that. So we need to return an actual runnable. So to do that, we're gonna do a system builder new, and that's gonna be move players and with query and build. And that's gonna take a command we don't care about, world resources and query. Right, I think that's what we need. Now we need to actually define the query here, and that's going to be query. That's a function. So we are going to need to write to the position and write to the player. And we are definitely not going to need that extra bit. And this needs to be a tuple. Like so, and I think that's fine. Now we need to get that. Use create pause, and now we should complain about other things, of course. Expected runnable system users build. Okay, you know what? That's gonna be build thread local, I bet. Yeah, and then, okay, so now, here we go. Here we have the problem. So we're not going to send the player across threads, but, and we're doing this as a thread local, but we still have to make the player implement send and sync. So unsafe implement send for player, copy and replace with sync. And okay, now that's fine. I mean, it is. We have an error somewhere else. You can see the error up here. But this part is fine. So this should give us whatever resources, and maybe we'll try to use delta time there. And yeah, so we got commands, world, resource, query. So it's all there. Okay, let's see what the problem is. Okay, the trait native classmate is not implemented for player. All right, no, of course not. So player. That's off the table. Can't do that. Right, and that worked. Okay, that's great. So now we have our system. We haven't actually done anything with the system, but now we have this set up. So let's go and look at our what we can do. We can just go to print move player here, and we have to add that. So it's happy, we don't need that or that for now. Excuse me. And let's see, what's this complaining about? Well, we're not using any of these things. They all are unused variables, okay? Just quite the warnings. So, okay, so if we now have some players, then we need to, well, you know what we need to do? We need to create the actual players as well. Which we should go and do a scene specifically for the player, and then we can just load the scene. It'll be a bit hacky, but we'll load the scene, and then we sort of instantiate that a couple of players once we start the game. Okay, so we're gonna do that now. Let's name that player, and let's get rid of that. We don't have that anymore, and let's save that as a new scene and delete that. Okay, that's it. We can come back and tidy that up. Okay, so let's get back to the code. Okay, so next up we're gonna add a function, and that will load the player or create a player, because we're gonna create more than one player. The idea of the game is that you're supposed to have up to at least 4 different characters at some point. So let's return kinematic body 2D here. So that means we need to add in the right place kinematic body 2D. We need a packed scene and a resource loader. Am I missing anything? So the resource loader will create a packed scene, which will instantiate and cast your kinematic body 2D. Okay, I think that's it. Okay, so let's say the loader is a resource loader, singleton loader.load player tsn into, so it's a Godot string, packed scene into, and then false because we want it to be cached. And then we say scene dot cast to a packed scene. At this point it is not a packed scene, it's a resource, I believe. We can see that if we do this. And it says, now it's an option. Okay, well, I mean, I could have checked what that was, but we're gonna have to unwrap this anyway. This function is not gonna be in the final product. Yes, it is a resource. Okay, so now the scene is being cast to a packed scene. We'll unwrap that, and then we'll create an instance of that. 0 is the default value. I don't think 0 or 1 matters unless you... Let's see, okay, it says not only available in editor builds. Okay, so 0 is the default one, so we can leave it at that. And this will create an instance, so I believe at this point, this is going to be a node. We best unwrap that. And that is a node, yeah, right. So... unwrap, and then we're going to cast the node to a kinematic body 2D, and then we're going to unwrap that too, and that should do it, except that it's an unsafe function. So let's wrap that in unsafe, tidy that up. Okay, so now we have a way of creating players. Now we need to add the ready function. And we are going to create a bunch of players here. Do 4. Create player. And then we need to add the player as a child of the owner. Child player. We are most likely going to have to make this guy mutable then, and that is probably unsafe. Add child. Okay, let me have a quick look at come on, man. Child, it takes an option and legible unique name. Okay, so it takes an option. And then, you know what? If it takes an option, we can just remove that and do this. Okay, and then it takes a legible name. No, we're not going to give it a name. We don't care about that. And then, right, okay, of course. We need a kinematic body 2D because we are going to put this in our system. So we're going to do player node equals player 2 node, and here we can make that into an option. So player node, that should do it. Right, apparently not. Called unsafe function. Okay, I'm guessing both of these are gonna be unsafe, so we'll just stick it all in there. Okay, so that's grand, that works. So now we create 4 players, and they're gonna be created on top of each other, which isn't gonna be ideal. It's not gonna be ideal. Okay, well let's just move the player. Okay, so player dot position equals vector to new. Let's take it. Alright, let's call that x, and there'll be x times 10. No, xs f32 times 10, and then stick it at 10. And that's not going to be position. It's going to be set position. And that's also unsafe, okay? Nothing is safe. Let's see, you can, okay, alright, okay. That's fine, there we go. Okay, so we're moving it 10 pixels to the right for every player we create. And then we add that China to see if this actually works now. So let's jump back into Godot. Okay, there we go. We can see our 4 players here. 1, 2, 3, 4. We should probably spread them out a little bit more. And we can see that our system is running as well. So, okay, let's go and spread the player out a little bit as well. And let's add them to the system. So let's see. Let's say that X is actually X as F32. Let's call this I. Times 10. And then we change that to, and then we add a plus to this as well. So let's add plus 10 and move it out a little bit more. And maybe we should say 20 and we move it down a little bit as well. Okay, let's give that a quick whirl. Turns out that was vastly incorrect. So we're going to say 5 plus 5. It was not right. Okay, so let's do this instead. Okay, there they are, and yeah, we can see the system is outputting move player. We should probably go and get rid of that. Right, there it is. Okay, so now we got players being added to this. So the next thing we're going to do is we're going to add the players to the we're going to create the entities that are the players. So we're gonna add some components together now. But first, I'm going to have a drink of water. Right. Okay, my sound is being a little bit flaky, and so let's get to it. So what we need to do is we need to add some components to the world so we can have the player move. We're just gonna make it move sort of downwards to make sure that the actual system is running. Okay, so let's fix this a little bit. So with world.insert, nothing, and there's no tags, and then player and position. Okay, and the player should be a player component, and the position should be a position component. You know, maybe it shouldn't be a position. Maybe it should be a direction, because we're going to move it. So let's find our position and call it direction instead. Okay, and then something broke, and in the player we have the position there. We're going to call direction instead, and down here we have direction. Okay, and we can read the direction. We don't have to write to the direction. So, right then, we should now be able to iterate through the query, passing in the world. So if we had both of these readable, then we could do that. But since one of them is writable, we need to do it immutably. And then we'll say for player direction in. And now this is really gonna be the player, is it? It's gonna be player.0. Okay, and this is all gonna be unsafe. Player.0.move and slide default, which is a function I have written, just does the default values for move and slide. Move 2D. So we can see what that does. Move and slide default. Let's find the implementation of that for something. There we go. For kinematic body 2D. So here's all the values, the default values that we're using for this. So the only thing I'm setting is the velocity and what qualifies as up. Since we're doing this top down, we don't have anything that qualifies as up. So we're gonna set that to 0. So we're gonna take our direction and we're gonna pass in a vector to 0 for up. We then need to add vector 2, and yeah, that's balked. Nope. Okay, right. Okay, so let's just finish this one before we go and fix all these errors. So we get direction. We're gonna multiply that by 100 or whatever. We should probably pass in the delta as a resource, and I think we can get it out from here. So let's look at that as soon as we got this working again. So that's our direction. Position is no longer a thing. And player needs to be an actual player. So what's this? Can't find position. So that is a bit sneaky, right? Right, okay, so the reason this is failing is because we're trying to pass player as a kinematic body 2D, and we have to wrap it in our custom player struct, which unsafely implements send and sync, right? So suddenly that's okay. And if we do that, do we have the player here? We do. Expected function. Private field. Okay, right. Let's go and make that public. And checking that my sound is still working. Okay, so that's now public. What's he complaining about now? Nothing. Come on. There we go. All right. So set position player.0 set position, and then we have a new vector, and then we can call adding a child. We need to pass in some, and let's pass in player.0.2 node, and get rid of that. And now we have other problems. Can't move. Because it's not copy. Is the equals 2. Let's do this. Okay, this is the kinematic body 2D, and do all that, and then player to node, and then wrap that in player. Okay. I needlessly complicated something. Right, so here we can actually pass in anything we want. Okay, and so that would define the player entity. Or well, we're calling this the player entity, but currently there is not really a name for this entity, but this is what we define as the player entity. And yeah, so we can pass in anything in there, and we have a destination. We have a direction, and then we're going to pass in a vector to new, and we pass in 0 for the x coordinate and 1 for the y coordinate. Okay. And now we should have 4 entities in our system that we can access based on this number here. So let's go over to player and see how this is going. And this is showing an error. Cannot borrow as mutable. No, that makes sense because we haven't said that it's mutable. And unsafe block. Right, so because I'm using my default, movement slider for that is probably implementing, it's doing all the unsafe stuff in there already. So that's fine. I don't know if 100 is going to be a lot or not. Let's take it down to 10 so we can actually see. I think now 100 should be fine. All right. So if this is correct, we should see the player moving. No, plus will be moving up. Let's do a negative value. Okay, hang on. That would be stupid. Come on. Let's go back and change the direction to be -1. There we go. Building, and that's okay. Let's run this again. Whoa, they went. Okay, no. That's absolutely wrong. The negative value is up and positive value is down. All right. Whee! Okay, so there we have our sprite moving very fast. Let's slow it down a little bit for no valid reason. I mean, it's not going to change anything other than the speed. But okay, so there we go. Our players are all moving, our characters are all moving in uniform down. So the next thing to do now is going to be to make these units selectable with the mouse. And I'm gonna save that for the next video. Okay, thank you.